Hola, mi clase. We are doing 7.4 today, equations with many solutions, infinite solutions, that's what sometimes it's called, and no solution. So I can give examples of equations with given number of solutions. So for 7.1 through 7.3, most of our answers were x equals a, or x equals a number, right? And so those are what we call one solution, because only one number works for the equation. So when we get x equals 10, that's the only number that keeps the statement true or equal, right? The only thing that keeps it true or equal is 10 or 3. So we've seen some examples that got us infinite many solutions. Remember, this is the one that said identity. Identity, there we go. I can spell, I promise. So where it was like 3 equals 3, right? Or 4 equals 4, when both sides were equal to each other, it was that infinite many solutions, because this will always be true. Okay, so when it's always true, it's infinite many solutions. And then we have a equals b, where a is not equal to b, right? So this is what we call this is no solution. And I actually don't like that it put a 0 here. So I want you to change this to no solution. And the reason why is because we can have a solution of 0. So I don't want you to think the answer is 0. It's that there is none. That doesn't work. So I want you to change the 0 to no solution, because that's the better way to say it. Okay? Because we can get x equals 0. Right? So I don't want you to think x equals 0 is the same as no solution, okay? So that's where we had like 3 equals 5 or negative 2 equals 6, right? They don't work ever. So I'm going to put a couple examples over here, right? So we have like x equals 10. That's a one solution. Where we have negative 2 equals negative 2. That's considered infinite many solutions because it's itself. And then for no solution, it's something like, like 3 equals 8. These do not equal each other, so that's why it doesn't work, right? These will never be true, no solution. We've seen a couple of these, right? So nothing super new. All right, it says use the properties of equality to simplify each equation, tell whether the final equation is a true statement. So properties of equality are just those inverse operations that keep things equal, right? So we add to both sides, we subtract to both sides, things like that. So we solve these just like we do in 7.1, 7.2, and 7.3. So remember, there's so many different ways we could do this. We can move the 4 first. We can move this negative 3 first. We can move the 2 first. We can move the 13 first. Remember that it doesn't matter as long as you follow steps. Personally, I would like to move the 2 first. That's just because that's the lower coefficient, right? So this cancels. There's my property of equality, doing it to both sides, and 4x minus 2x would get me 2x minus 3 equals 13. So now we would add 3, because that's the inverse of negative 3 or minus 3. We're going to get 2x equals 16. We're going to divide by 2, because this is 2 times x, right? So that's the inverse, so just divide. And we get x equals 2. So this is what we call one solution, because x equaling 2 is a true statement, because if I plug in 2 here and here, both sides would be equal. So x equals 2 is a one solution. It says tell whether the final equation is a true statement. You would say true. Okay? That's because, again, if I go 4 times 2, minus 3 equal to 2 times 2 plus 13. This is 8 take away 3. This is, what did I do wrong? Oh, you guys, I said 2 again. See, uh-oh. I can't divide apparently. Divide is 8. Let me try this again. 4 times 8 is 32. I got this. 2 times 8 is 16 plus 13. Don't worry, I fixed it. It's 8. This gets me 29 and this side gets me 29, and see, that's why it's true. X equaling 8 is going to be a true statement because this side equals that side. Alrighty, so let's do B. We're going to distribute by 2 first, only into the parentheses. So we're going to get 4x minus 5 equals 4x minus 2 minus 3, because we have to bring this down. It's negative 2 because it's 2 times a negative 1. Okay, don't lose that negative. So 4x minus 5 equals 4x, negative 2, negative 3 is negative 5. And just to fully finish it, I'm going to subtract my 4x from both sides. But the thing is that's going to cancel this one, leave me with negative 5. That's going to cancel this one. It's going to leave me with negative 5. And we would say this is infinite many solutions. You can also put the infinity sign, and we would say this is true. Okay, so again, it's if I plugged in negative 5, this side would in fact equal this side. So I'll prove it to you guys. If I go 4 times, oh, it doesn't mean plug in negative 5. You guys, I'm a mess today. It just means that no matter what I plug in here, and no matter what I plug in here, they're going to always equal the same. So if I plug in 0 here and 0 here, this will equal this. If I plug in 8 here and 8 here, this will equal this. So it'll always be equal to each other no matter what I plug in, like I did here. Here, up here on A, I have to only use 8. That's why it's one solution. Here I can put anything. For B, I can put any number I want to. Okay, any number. And it'll always be true. All right, last one. So this is a nice and easy one. We just need to move this 4x from both sides. We're going to subtract it because it's a positive, so that's the inverse. 2 equals negative 5. This is a no solution. 2 will never equal negative 5, and this would be a false statement. It's not a true statement because 2 will never equal negative 5. All right, so here is solve the following equations and state if they have one solution, infinite many, or no solution. So same exact thing we did on the front. How about you try the first one and see how it goes and see if what you get, one solution, no solution, or many solutions. Okay, so hopefully you pause like I asked you to. I would subtract 2x first, just because I like to move my variables first. Smaller coefficient, I get 1 equals 3x minus 8. I'm going to move this 8 now. Remember, if variables go from right to left, I need my my constants to go from left to right. I get 9 equals 3x because this cancels. I'm going to divide by 3, and I'm going to get 3 equals x. So this is a 1 solution because only one number works, which is in fact 3. All right, again, maybe pause, try this one, and see how it goes. All right, we are going to distribute first. We get 12x plus 9 minus 2 equals 12x plus 7. So 12x, 9 take away 2 is plus 7 equals 12x plus 7. Now, some of you could stop here and know that it would be infinite many solutions because the left equals exactly the right, or the right equals exactly the left. Right? These are exactly equal. Now, most of the time, though, you're going to be asked to fully remove and get 7 equals 7. Okay? A lot of teachers will ask you to go all the way down. So I like to just write the infinity symbol because it's quicker for me and easier for me. But if you want to write infinitely many, you can. Okay? Either or is fine with me. This just means that infinite many of numbers make this true. Okay, infinite many. All right, so here's the last one. I don't want you to go and solve it, please. So solve it all the way down. Tell me if it's one solution, no solution, or many solutions. I'm gonna leave that one blank. You guys need to do that one. All right, so just things to remember. Okay, whoa, that's really big. I'm gonna make it super small so it fits in this space. One solution, x equals a number. No solution, left does not equal the right. So that's like 3 equals 5. Okay, I'm a little bit out of room. If I go over here, there we go. Okay, and then infinite solutions, left equals exactly the right, and that's when we get, you know, -4. -4 equals -4. Okay, so they are perfectly equal to each other. I'm gonna slide that up just a little bit more so you can see it better. All right, there's your things to remember. So one solution, x equals a number. Okay, I can put an example there as well. All right, x equals 7. No solution, the left does not equal the right, so that's 3 equals 5. And then infinite many solutions is where the left equals exactly the right. So like that, -4 equals -4. All right, so here's your independent practice. It's similar to what we just did on the last couple of examples. Solve them and state if they're one solution, many solutions, or no solutions at all. All right, until next time, adios.